So we're asked to find the derivative of y with respect to x, and this is the equation that we're given to work with. So if we have a quick inspection of it, we can see that y appears here, and it's actually tied up inside a bracket which is raised to the power of 2. So one approach to this would be to try and rearrange the equation to get y equals. But if you try to do that, you're going to need to expand out this bracket, and you're going to end up with a y squared term and also a term with y on its own. So it's not possible to put it in the explicit form of y equals. So what that tells us is that we need to treat this as an implicit function and therefore do, well, not function, implicit relation, and therefore do implicit differentiation. So all that means is we basically jump straight in and take the derivative of both sides with respect to x in this case, because that's what we're interested in. So d on dx, which just means take the derivative with respect to x, and we'll write this out for this one here. Okay, so that's the left-hand side, we're taking the derivative, and for it all to be equal, we need to do the same thing on the right-hand side. So d on dx of 6x squared. Alright, so let's start by dealing with this first term here that we want to take the derivative of. Now something that might help you is rather than writing this as all over 8, if you wanted to, you could put it as 1 on 8 out the front, so then it's just a constant. So when we take the derivative of this now, we just need to apply the chain rule, and it's pretty straightforward since we want the derivative with respect to x and it's in terms of x. So top number times front number is going to give us 4 on 8. Well, that's the same as a half. We write out our bracket, we minus 1 off the power, which gives us 3, and then we need to multiply by the derivative of what's inside the bracket. So the derivative of x plus 2 with respect to x, derivative of x is just going to be 1, and 2, the derivative of that is 0. So timesing by 1, not really much happening there. Alright, so let's move on to the next term, which is the one with y in it, so it gets a little bit more tricky. Now I'm going to do this as just a bit of a sidestep to kind of explain the process, otherwise feel free to jump in and write it straight here. So we're looking for the derivative with respect to x of the 4y plus 2 squared. Alright, I've just copied this out and put it inside the bracket. So this is a little bit tricky because we have a y in here, but we want the derivative with respect to x. So what we can do is say, okay, let's start by taking the derivative with respect to y of our function. Okay, so that's pretty easy, but obviously this line is not equal to this line anymore, so we need to make it equal. So what we can do is say, okay, we want dx on the bottom line, so if I multiply by something over dx, I should be able to get that. We've got the d that we wanted, but we've got this extra dy on the bottom line, so we want to kind of get rid of that. So if I had dy on the top line, it would cancel with the dy on the bottom line, and thus I'd be back to having equal between this line and the one above. Alright, so that's basically just applying the chain rule. So let's go ahead and do it. So the derivative with respect to y here, it's going to be 2 times the front number, which is 1, write out the bracket, minus 1 off the power, so that leaves us with 1, multiply by the derivative of what's inside the bracket, so that's just going to be the 4 in front of the y, the 2 just disappears to 0 for the derivative. So that's this part here accounted for, and then we just have this dy dx on the end in order to make it the derivative with respect to x. Okay, and if we wanted to, we could clean this up, and that would be, the derivative with respect to x of that part of our function. So let's go back and put it in. Alright, so now all we've got left is the right-hand side to deal with. And again, this one's quite an easy one because it's in terms of x and we want the derivative with respect to x. So just a polynomial, top number times front number gives us 12, x, take 1 off the power, leaves us with 1. So that's all we've got. Now it's just a case of rearranging it because we wanted to answer with dy dx equals, so we just need to get this part of the equation on its own. So how I might start that is I'll leave this term altogether and move everything else to the other side of the equation. So that's just this part going over. So I'm going to get 12x minus a half x plus 2 all to the power of 3. Alright, so next I might divide by 8. So we're going to get 4y plus 2. So 12 divided by 8x. And then I've got a half divided by 8. So that's going to leave us with 1 on 16 in total. Like so. And then I just want dy dx on its own. So it's going to be equal to this, all divided by this. So if I wanted to, I could rewrite 12 on 8. That's the same as 3 on 2. And then bringing the other bit over, we're left with that. So that would be the answer for dy dx using implicit differentiation. So that's all there is for that video, and I'll see you in another one.